tomorrow. I believe it should be Tuesday. And it's on days 1 through 7. So starting off with day 1, we have tree diagrams. So remember, think back to tree diagrams, how we made those columns first. So if we have 3 chairs sitting in a row, or there are 3 chairs sitting in a row, how many ways can Angel, Brianna, and Connor sit? So we start out with the first column, the first chair. I don't know why my marker isn't. Come on. There we go. First chair, second chair, and third chair. Then we have our outcomes. Okay, so now we have that. Now we can start assigning people to sit in different chairs in the different orders. So we could start off with Angel first, we could have Brianna first, or we could have Connor first. Okay, so now what cannot go in? Who cannot sit in the second chair if we know that Angel already sat in the first chair? You're correct. It cannot be Angel because Angel cannot be in 2 places at once. So we know that it's either going to be Brianna or Connor. And then for if Brianna sat first, it's going to be that we're going to follow that same pattern. It's either going to be Angel or Connor. And then if Connor sat in the first chair, we can either have Angel or Brianna in the next chair. Now, here comes another tricky part. Now that we're going over from if we had Angel first and Brianna second, who's the only other person left that we haven't assigned a seat? It's Connor. And then it's going to follow. So if we have Angel and Connor, the only other person left is Brianna. Because remember, you can't have one person be sitting normally in more than one chair. I mean, I guess they could be laying across all 3, but this is not what the question's asking. So if we have Brianna, Angel, Connor, Brianna, Connor, then Angel's left. And I'm just going to continue. Now our outcomes, we could have A, B, C, C, B. Again, this should be really repetitive here. So by now you guys will have had a lot of practice with tree diagrams. So now we have our 6 different outcomes. And if you want to think back to our counting principle, you can think the number of ways, the number of options we have for this first column here. We have 3 options for the person sitting in that first chair. And then for that second chair, we only have 2 options here since we already sat someone down. And then for that last chair, there's only 1 more spot left. And 3 times 2 times 1 is equal to 6. And that's where that counting principle ties in. And again, we're going to go over it really quick down here as well. So now for the counting principle, the lunch special, you can choose an entree, drink, and 1 side dish. How many meal choices are there? Okay, so we have entrees, side dish, and drinks. Okay, so how many different drink choices are there? Well, there's 3. 3. That's where I got the entree from. So there's 3 options. Then for the side dish, I have green here. There's also 3 options. And then our drink, there's 4 options. So you're multiplying. So each category is, so we have our entree, that's 1 category. Side dish is our second category. Our drink. So each category is being multiplied by how many options there are within each category. So we're taking 3 times 4. And that's going to equal 36 different options, or meal options. So now as we move forward onto permutations, remember, permutation is a selection of group. Feel free to pause this if I'm going too fast, or you guys can rewind. Permutations, the number of permutations of n objects is given by n factorial. So let's say if there's 5 students winning random prizes for being really nice people, their names are drawn from a hat, how many different ways can the 5 nice students win the awards? So if I remember, my advice is to draw different slots for each award given. So there's 5 awards being given out. So that for that first award, then we have our second award, third, fourth, and fifth. That's why I drew 5 out. So the first award, we haven't assigned an award yet, so we still have 5 people to choose from to pick to get assigned that first award. And then remember how it goes down by one each as we move this way because there's one less person to be given the option to get an award. So that's why it's the same thing as 5 factorial. And 5 factorial is 120. Again, if you're still confused with what I was referring to here, there's more videos online. But the reason why I had 5 at the first slot here is because we haven't picked. So there's 5 students to begin with, and I hadn't picked one yet. But let's say I picked one for that first prize. So that second prize, there's only 4 students left because we already assigned one, and that follows through for the remaining slots. Okay, now we're evaluating what 8 factorial is. And then since we have 5 factorial up here, we know what's going to start off. Since it's 8 factorial, we start off with 8 times, and then it decreases by 1 each time. Times 7, times 6, times 5, times 4, times 3, times 2, times 1. Again, you can type this in on your calculator. And for really big numbers, I suggest that you find that factorial key on your calculator, just exclamation mark. You hit math, and then you scroll all the way over to probability, and then you go down until you hit that little exclamation mark number. And the 8 factorial is the same. It's a pretty large number, so it's 40,320. If I typed that in correctly, I think I did though. So now we're going on to permutations from a subset. So now, okay, permutations of n total objects with r objects taken at a time. So again, I highly recommend you know how to type this in on your calculator. I wouldn't really so much recommend doing this. This is just another way you can check your answer, but I wouldn't recommend doing it that way. Instead, I recommend that you draw out your different slots. So how many ways can a stylist arrange 8 vases from left to right? Let's figure out what our n and our r is first. So there's 8 total vases, so we know that's our n. Okay, and then our r would be the 5 vases that we're selecting. So we're selecting 5. So we're only going to have 5 different slots. So 1, 2, 3, 4, 5. Okay, so again, you could either then, now that we know, so first spot, second, third, fourth, and fifth. Now we have to think back to our n objects. How many different vases could go into that first spot? It's going to be whatever our n is, and our n is 8 because there's 8 vases that we have total, so there's 8 options there. And then that's being multiplied by, and remember how it goes down, each one, because if you already picked one, there's one less option for you to have for that second vase spot. And it's going to continue all the way through. Think, what is, since you've already picked, if you're assigning vase number 3 and you already picked 2, and you started out with 8, you can take 8 minus 2, and that gets you 6. And then 8 times 7 times 6 times 5 times 4 is 6,720. You could do it this way, but as we move into probability, I want you guys to know how to find this in your calculator up here. And since we know our n is 8, so we can have 8p5. And once you type that in your calculator, you're going to get that same answer. Okay. Now we're going into permutations with identical items. So how many ways can you arrange the letters in the following words? So we know that it's